Dear students, I am Sarojini Naik from ENTC Department, Modern College of Engineering. Today we are discussing one of the important topic of unlock circuit, that is voltage to current converter and current to voltage converter of Unit 6 Converters and PLL. So this is the course objective and course outcome of Unit 6, and here is the list of reference books and test books along with some NPTEL courses. First, voltage to current converter. As its name indicates, it is a circuit which converts the input voltage into proportional output current. These converters are essential because in instrumentation and automation industry, when sensors convert the physical quantities like pressure, temperature into proportional voltage, if we transfer that voltage for a long distance, for a data acquisition system or to display, that voltage gets decayed over a distance. So if we convert that voltage into current and if we transfer for a long distance, current will get less decayed, or the current gets decayed very less. That's why it is necessary to convert voltage into current in such applications. So we have two types of voltage to current converter. First one is floating load voltage to current converter. As its name suggests, floating load means load resistor is floating. In other words, it is not connected to ground. And in the second type is grounded load voltage to current converter, where load resistor is connected to ground. So first we will start with the first type, that is floating load voltage to current converter. This is a circuit. Here the op-amp is used in non-inverting configuration because the input signal is given to non-inverting terminal of the op-amp. So we are converting this given input voltage Vin into proportional output current. Output current means load current. Here the inverting terminal is driven by the negative feedback. Okay. Due to this negative feedback, the potential at inverting terminal will be same as non-inverting terminal potential due to virtual short. So if we analyze mathematically, this input voltage is nothing but this Vd differential voltage plus this feedback voltage. But we know that this differential voltage is 0 since A is very large. That's why we can say that this input voltage is equal to this feedback voltage. Here the feedback voltage is nothing but R into IL, because this IL is completely transferred to this resistor R because IB is 0. So IL is nothing but V in by R. So what we can see is that the load current is independent of load resistor, and the second thing is, if R is fixed, then the load current is only depend on the given input voltage. So the input voltage is converted to proportional output current independent of load resistor. Our second type is grounded load voltage to current converter. Here we can see that the load is grounded. In the previous case, the load was not grounded. There was no grounded for this load. Here, load is grounded and the op-amp is used again in non-inverting configuration. In this, we can say that this IB is 0 due to high input impedance. So, input will be converted into proportional output current. So, if we analyze it mathematically, we can say that, see here we can say that I1 plus I2 is equal to IL. For this I1, I can write it as V in minus V1 by R, and for I2, I can write it as V0 minus V1 by R. Okay. So, if we simplify that, we will get it as V in plus V0 minus 2V1 equal to IL into R. If we write the equation of V1, it will become V in plus V0 minus ILR divided by 2R. Since the op-amp is connected in non-inverting configuration, the gain is 1 plus RF by R. In this case, RF and input resistor both are R, so the gain will be 2. So, the output voltage is 2 into input voltage, that is V1. Okay. So, if we substitute this value, it will become V in equal to IL into R. If we substitute this in this equation, so it will become V in equal to IL into R, that is IL equal to V in by R. That indicates that load current is completely independent of load resistor RL, and if R is fixed, IL is dependent on V in and R. Now, the applications of voltage to current converter, it is mainly used in Zener diode tester, automation and instrumentation industry, low AC/DC voltmeters, testing of LED, testing of diodes. Now, the next topic is current to voltage converter. It is exactly same as voltage to current converter, in which in the previous case it was input was voltage and we were converting into proportional current. Now, the thing is that input is current, we are converting into proportional voltage. The output voltage is proportional to the input current. It's except the input current and is the output voltage V0. So that V0 equal to A into I, where I is the gain of the circuit. Since A is measured in ohms, it is more appropriate to denote it by the R. So this is the circuit diagram of current to voltage converter. So it is a typical application of inverting amplifier. In this, node A is at virtual ground because B is grounded. VA equal to VB, that is equal to 0. II will be VA minus V0, VA minus V0 by R, that is nothing but this current II. So it will be minus VA is 0, so minus V0 by R. I can write V0 is equal to minus II into R. So it is nothing but output voltage is proportional to input current. So here the applications of voltage to current converter, it is used in mainly analog to digital converter and the automation and instrumentation industry in current sensing application like current sensing through photo detector that such as photocell, photodiode, photovoltaic cell, where the output will be current, but for data acquisition system we require voltage to store it. That's why it is necessary to convert that current into voltage. In such applications we are using current to voltage converter. Thank you.